In this video, we're going to start talking about confidence intervals, kind of a basic overview of what they are and the arithmetic behind it. And then as we move on, we'll start talking about what they're used for and put them into applications. But today is a pretty light, like arithmetic type of video. Okay, so here we have section 8.1, confidence intervals, and it says a point estimate is a single value or a point used to approximate the population parameter. So the population parameter, that's the word all the way from chapter 1. Parameter is a number used to describe the population. So we're trying to narrow that down to a single number, or single point. And we're going to do that two different ways. Now, in the next few chapters, not just chapter 8, but we're going to be talking about proportion, and we're going to be talking about mean. So the sample mean, we already know, is X bar. The sample proportion is written like this, and it's pronounced P hat. So it's just the little thing on top is just a little hat, and we just call it P hat. Silly name. Okay, so the sample proportion is the best estimate for the population proportion, which is just a lowercase p without the hat. And the sample mean, X bar, is the best point estimate for population mean, which we already know is mu. So we have X bar and mu, which we already know. And so now we have P hat and P. The difference between the sample proportion or the sample mean and the population proportion or mean is called the margin of error. So let's just jump, we'll do this paragraph in a second, but let's just jump down here to see what I just said. So we have a number in the middle here. This is an interval. It goes from small to big. And in the middle, we would have the mean, the true mean, population mean. And we're saying it ranges from the sample mean minus the margin of error and the sample mean plus the margin of error. So somewhere in that range is the true mean. Same thing with proportion. We have the sample proportion minus the margin of error all the way to the sample proportion plus the margin of error, and the true proportion lies somewhere in there. So we're just coming up with a range, an interval, where we think, based off the data, the true mean or the true proportion lies, the population. Okay, so going back here, it says both the point estimate and the margin of error are used. Okay, that's what we just said. This is a confidence interval. And we'll talk about like how confident we are, all that in the next video. Right now, we're just doing the arithmetic of how to create a confidence interval. It's a range of values to estimate the true value of the population parameter, either the population mean or the population proportion. And sometimes it's abbreviated as CI. Okay, so we're going to use this definition in multiple ways today. And so to start off, so all you need right for today is just the calculator. Is just basic plus and minus and maybe division in here. So here we have a problem, and it says we're constructing a confidence interval. A student wants to determine the mean amount of rain that a certain city receives in April. To estimate the unknown population mean, because we don't know what mu is, she uses sample data to calculate the estimate. So we know the sample mean, X bar, and then we know the margin of error is 4. So we want to construct a confidence interval for the mean amount of rainfall. So what we have here, using the formula above, we have a parenthesis because it's an interval. This is just like an interval from algebra. And we know that this is 72.25 minus 4, all the way up to 72.25 plus 4, because 72.25 is our X bar. And then 4, we're going to subtract and add 4 for our margin of error. So we come over to our calculator and we do 72.25 minus 4 and 72.25 plus 4. So our answer is going to be 68.25 to 76.25. I just put the space in between the period, or in between the comma, just to kind of separate it. It was kind of bunched up earlier. But that is our interval. That is our, just going to cover it up. Oh, I messed up the rectangle in a past video and I can't fix it. Maybe I could put a circle around the final answer. Aha, that's the final answer. Okay, so this is our confidence interval. And I highlighted mean just to show you that we were talking about mean. But you'll notice the formula is exactly the same. So it doesn't matter if we're using mean or proportion. We're going to subtract to get the lower and add to get the upper. And as a reminder, smaller numbers are on the left. That's a subtraction. Bigger numbers are on the right. You have to write these in number order because it's just like writing a word. You have to spell a word in the letters in the right order. Because otherwise, if you spell a word backwards, people don't read that way. So we have to read our numbers the same way from left to right. Okay, next up we have a proportion. So it tells us in the problem that the proportion of those surveyed is 0.46. And it says, oh, the font looks a little weird, but the margin of error is 0.03. So our confidence interval is going to be our proportion minus, give a little space, minus our margin of error, comma, our proportion plus our margin of error. Proportion, probability, all the P words go together. So proportion will always be between 0 and 1, just like probability. So if you're not sure if you have a proportion problem or a mean problems can be any numbers. Proportion problems can only be between 0 and 1. Okay, so I'm going to put this into my calculator. So I have 0.46 minus 0.03 and 0.46 plus 0.03. And that is going to be my final answer in number order. Here's my confidence interval, 0.43, comma, 0.49. And if you do that in your head, cool. You don't need a calculator if you don't want it. So here is, oh, get that over there. Where's my symbol? Here is my final answer. Okay, so that's how you construct a confidence interval. And we are going to use these formulas where the plus and the minus is the lower, the plus is the bigger, throughout this section. But we're just going to solve for different things. So this first one, we made a confidence interval. And now we're going to calculate the margin of error if we already know the confidence interval. So notice up here in our formula, the margin of error, as we did in these problems, that's what we're adding and subtracting from our X bar. So we have our confidence interval is 110 to 195. And we want to find the margin of error. Okay, so to figure out what number is being added and subtracted from these two numbers, we're just going to take the biggest minus the smallest. So here we have, basically I have a number line. Well, I don't need to show them. Okay, I'll just write it out. We're going to take, for the margin of error, we want to take the biggest minus the smallest. And then we are going to divide that by 2. Here's my line. Divide by 2. So we have over here on our calculator, and I like to put parentheses when I'm doing the subtraction fraction. That's right, subtraction fraction, because then when I hit divided by, it all goes over the top. And I see, yes, that's the right answer, the margin of error. Perfect, 42.5. Yeah, 42.5. Okay, sorry. It looks weird because there's a decimal and I didn't see a decimal, but that's okay. Perfect. So what we're saying, so this is the answer right here. Let me circle it and then I'll tell you what we're saying. What we're saying is there is some sort of number. We don't know what the number in the middle is. Here's text. I don't know what are we doing mean? I don't know what X bar is, but 110, comma, 195 is the same as saying X bar minus 42.5. where did okay, well, I messed that up. X bar minus 42.5, comma, X bar plus 42.5. I don't even know what X bar is. Let me just put my bars on here. We will calculate how to find X bar in the next example. Somehow, for some reason, they need to be like ridiculously above. There, I'll move the bars close. Okay. We'll talk about down here, calculate a point estimate. We'll talk about how to find X bar. But if we're just finding the margin of error is the 42.5. That's the number we're adding and subtracting. I got tricked because there was no other decimals and the answer's a decimal. That's okay. X bar could have a decimal too. And if I add 2 decimals, it can equal a whole number. So don't be tricked like me. Add them up, divide by 2. If you add 2 things and you divide by 2, the answer is either a whole number or a half. Those are the only choices. So you're going to see lots of halves on these. Okay, let's try this again. That was for the mean. Now we're going to do it for proportion. And so we have Kevin randomly sampled a group of student athletes and asked whether they ate a snack before practice. The resulting confidence interval for proportion for students who eat a snack is this right here. So again, everything's between 0 and 1 because we're talking about proportion. But other than that rule, everything else is the same. So margin of error is going to equal our smallest number, our biggest number, minus our smallest number, and then divide by 2. It has to be the biggest one first because it has to be positive. But other than that, we're just subtracting, dividing by 2, and come over here to my calculator, get my parentheses, 0.85 minus 0.69 divided by 2, and we have teeny tiny number 0.0 equals 0.08. Again, the only rule is that it has to be between 0 and 1, so it doesn't matter that it's a teeny tiny number. That is our margin of error. That is the number that I'm adding and subtracting to p hat to get the answer of 0.69 and 0.85. Okay, last but not least, we want to find the point estimate. So here we found the whole interval. Here we found the margin of error, ME. And down here, we're going to find the point estimate, which is either p hat or X bar, depending on which problem we're in. So here we're in the mean height. So what we want to find is X bar for this problem. So X bar is going to equal, now this time, we're going to add them up and divide by 2 to find out exactly what's in the middle. Notice this number, 0.08, is not in between those two numbers. So that's perfect. That's what we wanted. But this answer that we're going to get here is going to be somewhere in the 40s or 50s. It needs to be right in the middle of those two numbers. So we're going to add them. It doesn't matter the order because we're adding, addition order doesn't matter, but I like to just do it the same. I like to do the bigger number first. That way, every time I add or every time I subtract, every problem I do, I'm just putting the biggest number first and the smaller number second. Okay, so X bar divided by, or no, that number divided by 2. Again, I'm going to use parentheses on my calculator because let me just show you what happens if you don't. I think I've done this before, but 59.7 plus 46.8 divided by 2. See how the second one goes up? I don't want to do that. So let me try this again with parentheses, 59.7 plus 46.8, close parentheses. Now when I hit divided by, everything goes up. Divide everything by 2, and I get 53.25, which is perfect. Remember, mean doesn't have a restriction, so it's fine that it's 53. And also 53.25, what I'm saying is that is the number right smack dab in the middle of these two. It's halfway in between those two numbers, hence the divided by 2. So point estimate, either X bar or P hat, which we're about to do. Point estimate is add and divide by 2. Margin of error is subtract and divide by 2. Okay, last but not least, we have the population proportion. And so we want to find the sample proportion. We want to find p hat. I don't know that I can draw a hat very well, so I'm just going to write p hat. And that is going to be our two numbers added together and then divided by 2. And so when we do that, we go to our calculator one last time. 0.84 plus 0.72 close parentheses divided by 2, and I get 0.78 as my final answer. That is the number that is right in between 0.72 and 0.84. It's halfway in between. Another way you might have seen this written or talked about before, like in algebra, this is the same as the midpoint formula. So if I want to find the point right in the middle, I just add them up and divide by 2. And then if I want to find what I'm adding or subtracting, the margin of error, I subtract them and divide by 2. All right, again, this video is short and sweet and just about arithmetic. If you have any questions, shoot me an email. Otherwise, we'll get a lot more into why we're even doing this in the next video. Bye.